Hi folks, we're going to take a look at an exemplar of solving a trigonometric equation that's going to have exact solutions, or where we can find exact solutions. So here we have cos squared of 2x equals 3 over 4. So again, I'm going to follow the same steps as I did before, which step number 1 here is to isolate the trig ratio, which in this case here is going to be cos 2x. So in order to do that, I have to take the square root of both sides. So here we have cos of 2x is going to be equal to, now remember, plus or minus square root of 3 over 4. But when we do a little bit of simplifying here, we realize that we have root 3 over 2, okay, which of course is a ratio which corresponds to a special angle, all right? So when we go to step 2, which is to find two answers for the trig ratio in one cycle. In this case here, it'll actually be 4 answers, because it'll be 2 answers for the positive square root of root 3 over 2, and of course the negative one. All right, so let's use our Cartesian plane to figure out where this is going to be. So here, I know this is either going to be pi over 6 or pi over 3. So since it's cosine, it's the x that's the longer side, so it's going to be pi over 6. Okay, and of course, where else is cosine equal to positive root 3 over 2? It's going to be in the fourth quadrant, which is 11 pi over 6. All right, but I'm also solving cos of 2x equaling negative root 3 over 2. So I'm going to do this all in one shot here. So where is it going to be equal to negative root 3 over 2? Well, it's going to be in the second quadrant. Okay, so 5 pi over 6, and in the third quadrant where cosine is also negative, so 7 pi over 6. All right, so these are the 4 solutions in one cycle where cos 2x is either equal to positive or negative root 3 over 4. Okay, so that means that 2x can be equal to pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, now again, we have 4 answers here because I'm actually solving 2 different equations, one where it's positive, one where it's negative. Okay, so now we go to step 3, and step 3 is to isolate the variable. So here I just have to divide all of these by 2. So it's going to give us pi over 12, 5 pi over 12, 7 pi over 12, and 11 pi over 12. All right, and step 4 now is to generate all the other answers, because obviously these are only 4 of what's going to be quite a few other answers in this range. Okay, and in order to do that, we need the period of the trig ratio that we're working with. So the period, of course, is just 2 pi over the k value, which in this case is 2. So our period is just equal to pi. But in order to make my life easier, I'm not going to think of this as pi. I'm going to think of this as 12 pi over 12. So I can do my additions and subtractions more easily. And I think I will have to do some subtractions since we are going into the negative. Okay, so let's look at our other solutions here. So first, let me start by adding 12 pi over 12. Okay, so what do we have? 12 plus 1, so we have 13 pi over 12. This is going to give us 17 pi over 12. This is going to give us 19 pi over 12. And this is going to give us 23 pi over 12. Okay, so if I try to add more, so you have to think 2 pi is 24 pi over 12. So if I try to add even to this one here, 13 plus 12 is 25. So I'm going to stop, because otherwise I'll go beyond my range of values. Okay, so of course, though, we can also subtract. So now we're going to start subtracting the period. Okay, so let's see what happens. So I'm going to do that from these original values. Okay, I'm going to subtract 12 pi over 12. So what do we have? This is going to give us negative 11 pi over 12. 5 minus 12 is going to be a negative 7 pi over 12. Okay, 7 minus 12 is negative 5 pi over 12. And then here 11 minus 12 is going to be negative pi over 12. So these are also correct answers. And I think I can go a little further, because if we take the smallest one here of them all, negative pi over 12, 11 pi over 12, is just a little bigger than negative pi. We can go all the way to negative 2 pi. So Let's keep going. Let's subtract 12 over 12, 12 pi over 12 again. So here, what do we get? We're going to get negative 23 pi over 12. This is going to give us negative 19 pi over 12. This is going to give us negative 17 pi over 12. And this is going to give us negative 1 minus 12, negative 13 pi over 12. Okay, and I think that's as far as we're going to go, because if I take the smallest value here, or even the largest value here, if I subtract 12 pi over 12 again, I'm going to be less than 24 pi over 12, which of course is what negative 2 pi is. All right, so here we have in total 16 different answers possible to solve this equation on this range here. All right, so let's recap. So you'll notice that even though I was generating exact answers, the steps for solving the equation are the same. Solve for the trig ratio. Okay, in this case here, we took a square root, so we actually had two different equations that we generated, cos 2x equaling positive root 3 over 2, or cos 2x equaling negative root 3 over 2. Because root 3 over 2 corresponds to special angles, instead of using my cos inverse button, I used my special angles, and I realized that pi over 6, 11 pi over 6 solved the positive one, and 5 pi over 6, 7 pi over 6 solved the negative one. So from there, I get 4 answers. I then isolated my variable, all right? And then from there, in order to generate other answers, I added or subtracted the period of the cos ratio until I got all the answers within that domain of values that was given. Okay, that's it for this one.